In this video, we are going to talk about which statistic to use. At this point, you know two statistics, the z for the individual score, which uses this equation, and the z for the sample mean, which uses this equation. Now, choosing between these two doesn't have to be difficult. When you read a research situation and they say anything about a sample mean, what's the probability of sampling a sample mean that is less than 50, for example? You want to use this equation. I mean, it's got a mean in it. If, on the other hand, you're reading a situation and it says, what's the probability or what's the percentage of people above this score? Now, percentage of people, it doesn't mean group of people. It wants to know how many individuals are above or below a certain score. So in a situation like that, you want to use this equation. And you'll get to see some examples in the activity today, so that's a skill that you want to try and hone in on. Now here what we have is a distribution of scores from a population with known parameters, a mean of 25 and a standard deviation of 4. And we're going to ask this question. What's the probability of sampling an individual score, a score of 20 or lower? The first thing we'll do is we will fill in the known parameters. Well, we know that the mean of the population is 25, and we're going to go up and down from that mean with standard deviation steps. In this case, that's 4 units up and 4 units down. And I've done that with that green number line there. The next step to do is to convert that green number line into a z-score number line. And we can do that here. The 25 is always going to be 0. The mean of any distribution in z-score language is going to be 0. And then you move up and down in z-score steps, in other words, one unit at a time in a z-score step. And how large is the z-score step? Well, the z-score step is always equal to the standard deviation. That's why we went from 25 to 29, 29 to 33, and then we go down from 25 to 21 and 17. All right, now the next thing we want to do is we want to use this equation. And then we just want to substitute in the scores that we have. The score is the 20 from the actual question. And the mean, is the 25, and the standard deviation is 4 from the original question. So we substitute those numbers in, and then we crunch the numbers, and we get a z-score of negative 1.25. Now we have to find that on the curve. It's negative, so it's on the left-hand side of the curve. And so we're going to draw that right there, fill in that area. And now the question is, how much of the area of this entire curve is equal to or less than 20 in terms of the raw score language, or equal to or less than negative 1.25 in the z-score language? And you need to look that up in the back of the book in Appendix A again. And if you do that, you look up 1.25, and you know it's a tail because it's the smaller of the two portions that the line made. And now we see that it's slightly more than 10%, or 10.5% of all possible scores that could be sampled are going to be equal to 20 or less than 20. So the probability of you sampling out one score, about 1 in 10. All right, now we're going to change the question slightly. What's the probability of sampling a sample mean of 20 or lower? Well, it depends on the sample size, right? So the first thing we have to do is decide on a sample size. And normally that's going to be given to you in the question, what the sample size is. Well, in this case, we're going to use a sample size of 4. So I've got this curve drawn here. Now this is going to be not a population of scores, but rather a population of sample means. In other words, this is a distribution of sample means. And in order to answer the question, we need to start filling in the information that we know. So the mean of this is going to be 25, because of the central limit theorem tells us that the center of the distribution of sample means is going to be equal to the center of the population mean. That's why they're both distributions are going to be the center of 25. The next thing we need to do is figure out the steps to the right and the steps to the left. How big are they? Well, we figure that out by using the SEM, the standard error of the mean. We plug in the numbers we have, the sample size and the standard deviation from the population, and we get the SEM of 2. In other words, we're going to step up and step down from 25 in 2 units. So we go 27, 29, and we go down 23 and 21. And now we can convert that number line into a z-score number line. The same logic we did above. The mean is always 0, and then we go one standard error of the mean step up rather than one standard deviation step up to get the z-score. Again, we're using a sample size now, so we have to use the SEM, not the standard deviation, to determine how large or how small the steps are in z-score language. And now we're ready to run through the equation. Now we're going to use this equation, again, because we're using a sample mean, not a individual score. We substitute in the numbers that we have, and then we run through the numbers, and we find a z-score of negative 2.5. We need to find that on our curve. And I'm going to extend the curve out a little bit, just because I didn't quite draw it long enough. And to make it symmetrical, I'll do it on the other side. And now we want to find the area. So we're going to shade in negative 2.5. That'll get us about there. Find it on the z-score number line. Draw it down. Okay, and negative 3 is about here. So negative 2.5 is right between those two numbers, obviously. And now we want to do is find the area that we've shaded in. How much of the entire area? Notice that the area is quite a bit smaller than it was in the first problem we did. That's because we're using a sample of 4 people now, not one individual score. So we should expect it to get quite a bit smaller probability, because we'd have to get 4 people with an average of 20 or less. And that would be pretty hard to do. And so we're going to shade this area. We find that the probability is 0.0062. That means less than 1% of the time, 6 times out of 1,000, would you by chance sample 4 people and have their mean be equal to 20 or less. Now let's look at what happened here. If you look at the first problem, the standard deviation, the size of the steps, in other words, sampling error, the size of the steps to the left and right was 4. In the second equation, sampling error, the size of the steps, was equal to 2. By increasing the sample size from 1, that's really what you could think of as the top problem. N up here was really 1. We're taking 1 score, right? If you just take 1 score, in between 10% of the time, 10 and 11% of the time, you're going to sample a score that's 20 or below. Excuse me. But when you increase the sample size to 4, you're going to cut the sampling error in half. It was 4 and now it's 2. That's a good lesson. If you increase the sample size by 4 times, you're going to cut the sampling error in half. All right, hopefully this will give you an idea of how to use the 2 equations and in what situation to use those 2 equations. You'll be using that skill today.